Hey everyone, Joe here, and welcome to Lecture 4.4 in Module 3 for RAD 104. So in this lecture, I'm going to start talking to you about measuring patient dose, and the main way that we do that is something called entrance skin dose. And so this is important because leaving from the last lecture is that we see that there's an increase or a rise in medical imaging procedures that give patients an increased radiation exposure because of all of the medical imaging modalities there are, and because of the number of exams that people go through every year. Now, there are different kinds of patient doses that we record or we study. The one I'm going to focus on is entrance skin dose, and that is the one most relevant to diagnostic radiography. Gonadal dose and bone marrow dose, I'm just going to give those a flyover. Maybe you'll discuss them a little bit more with Russ in the fall, but just so you know what they are and how they're used. But for all intents and purposes, we are going to really focus in on that entrance skin dose, and you'll find out why. All right, entrance skin dose. So what is entrance skin dose? Entrance skin dose is simply patient dose. It's just a fancy way of saying patient dose. And it is exactly what it says it is, entrance skin dose. So it is the radiation that hits the top of the skin of whatever is being x-rayed. So how much x-ray is hitting the skin at that point, that's what entrance skin dose is. It doesn't take into account the different types of tissues underneath. It doesn't look at the organs underneath. It just looks at how much x-ray, how much radiation is hitting the skin as it enters the body. That's what entrance skin dose is. So then the question becomes, well, how do we measure this? How do we know how much radiation dose is entering in the skin? Luckily, now that we're on digital, we can actually determine how much x-ray is coming out of the tube. I know that the GE rooms in the emergency room at Beverly, and I think, I'm not sure about the Fuji rooms at Salem now, but I know for a fact that they will show you how much exposure was coming out of the tube at the tube level. And so that's helpful. But there's other things that we can do to help determine what an entrance skin dose is, and we're going to look at those now. So to determine a patient's skin dose, or entrance skin dose, we can use these basic charts that kind of give us a ballpark of what the entrance skin dose is. And those graphs, those charts are called nomograms. And I'm going to show you a couple of examples in a second. Before I get there, though, another way of figuring out what the entrance skin dose is that you can have a medical physicist come in and they will perform different tests on the tube to determine what the intensity of the x-ray is coming out of the x-ray tube. And by knowing that and knowing what type of exam it is, they're able to use mathematical equations and formulas to come up with the ESD for that type of exam. Another way of doing it is that they have ballistic gel dummies or mannequins, and what they do is they will tape a TLD, a thermoluminescent dosimeter, right onto the body part. And so they will take an x-ray. Let's say they're going to do an abdomen. They'll tape a TLD to the abdomen of the ballistics gel dummy. And they will take an abdomen exposure, and whatever shows up on that TLD as far as exposure is concerned is what the entrance skin dose is. It's a pretty simple way of doing it, but pretty accurate because those TLDs are accurate within 5% of what a normal ESD would be. So that's a pretty simple way of doing it and pretty good. All right, so let me skip to the nomograms. So a nomogram is just a chart or a little graphical representation of some things, and it will help us determine what the exposure will be. They're very, very easy to use. There's different kinds of nomograms. I'm showing you two different ones here, and I'll show you how these work. All right, so this first nomogram. For this one, in order to use this nomogram, you need to know how much filtration your x-ray tube has. Now, if you're using a diagnostic x-ray tube, you have to have at least 2.5 millimeters of aluminum equivalent. So let's start with that. So total filtration, millimeters of aluminum. So if we start right here where my mouse is, all right, and we need to know how much kVp we're using. So let's pretend we're doing an exam with 60 kVp. So if I raise up my mouse up to 60 kVp, that goes on to this graph here because it's based on 60 kVp. And then I move over to the left, and so I'm getting approximately whatever this line is, or around these lines. So 1, 2, 3, say 3.5. All right. So then my entrance skin exposure would be about 3.5 milligray per 100 mass at 100 centimeters of SID. If you're listening to that and you're getting a popsicle headache, don't sweat it. As long as you know that the nomogram, you need to know the total filtration, you need to know your KVP, and then we can do this formula based on distance, but that'll give us our basic entrance skin exposure, so entrance skin dose. So that's number one. I'm not going to get into this much detail on the test, as long as you know that a nomogram is a graphical representation or a tool that we use in order to determine what the entrance skin dose is. This one is a little bit easier. So you pick your KVP. So again, let's use 60 KVP. All right. What's our mass? So let's say we used 60 KVP and we used 10 mass. So if you draw a line from 60 to 10, that'll give you this number here on the line, and that's what your ESD is. So very, very simple. It's not too difficult. You don't need to know too much about this just because you guys aren't medical physicists, but you should at least know what a nomogram is. It helps you get your entrance skin dose, and that's pretty much it. One thing you need to remember with entrance skin dose is that you can protect against that by having a larger SID. This is one of the reasons, or this is why we're looking at maybe changing SIDs of 40 inches and maybe going out to something like 54. Is that the closer you are to the source of the X-ray, the more intense it is on the skin. Don't forget that that beam is going to be divergent. It's going to get wider. And so it's less intense the further away you are from the source of the radiation. So the higher your SID, the lower your entrance skin dose. It's going to be less volatile to your skin because you're farther away from that real intense beam. Okay, by giving it more distance, it diverges. It's not going to be quite as intense on the skin, and you're going to have less likely of a chance of having some type of radiation burn. This also gets back to the point of, don't forget, when you're dealing with a fluoroscopy unit, more importantly a C-arm, that the source of the radiation is at least 12 inches away from the person's skin. Okay, and if you're using a fixed fluoro unit, like in a fluoro room, that X-ray tube needs to be at least 15 inches away from the person's skin. So it is because of this that we're very cautious of that, and it is the reason why we're considering maybe changing someday, going from a 40-inch SID to a 54. And that's pretty much it for ESD, or entrance skin dose. The one thing I did want to mention is that I do see as we move forward into the future, eventually we're going to start tracking everyone's dose, regardless of what X-ray it is, whether it be fluoroscopy, CT, or just a regular extremity X-ray. I think you're going to start to see that inside patients' charts, just like Epic, we're going to have to record what the ESD or what the exposure was coming out of the tube that hit the patient. So I think we'll see more of this as we move forward. All right, the other two types of dose that I want you to be aware of, one is called gonadal dose, and that kind of looks at, and sometimes it's called genetically significant dose. The reason why this is important is if you think back on it as to what are the things that we're nervous about with radiation in human beings. One are, are we going to have a stochastic result as far as an increased rate in cancer levels? And the other thing that we're concerned about is passing on mutated genetic information to future generations. So this dose just looks at the dose affected or impacting the gonads, changing the genetic code being passed on to the next generation. Does this have anything to do with diagnostic X-ray? No. The amount of X-ray energy levels that we are dealing with are not going to affect gonadal dose whatsoever. This type of dose is really used for large-scale epidemiologic studies that involve lots of people over a long period of time. So you're looking at exams, you're looking at different age groups, you're looking at the number of children that each person has had, who has received any type of X-ray or radiation to that area of the body. And it looks at these enormous studies with thousands and thousands of people. Not really relevant to what we do, but you should know what it is. And again, these are the studies we use to see what are the genetic changes that could affect future generations. The other dose that you should be aware of is bone marrow dose. Once again, though, we're dealing with a large study over a long period of time with lots of people, and what we're looking at is a radiation dose that affects the entire active bone marrow. With diagnostic x-ray, you really don't see that, but if someone does, and the effects and the chances of having any type of hematologic effect because of a diagnostic x-ray are virtually nothing. So this is looked at to look at populations or the risk of populations having late effects of radiation such as leukemia and any type of cancer or melanoma. So again, something that we really don't need to worry about as far as x-ray techs are concerned, but you should at least know that in order for us to study those stochastic effects of cancer related type of effects based on radiation, we have bone marrow dose studies. All right, everyone, and I'm going to leave it at that. If you have any questions about this, please let me know. You know, the main importance out of this little lecture was understanding entrance skin dose and patient dose and how it is determined and how I see it going forward into the future. It's going to be something that we're going to have to track. So any questions, let me know. I'll see you at the next video.